Okay. So in my last video, I talked about the idea of the main principle behind differentiation. So what we're doing here is we'll be using that principle to get the basic derivative of of basic functions. And before I go to what I'll talk about, let me get out the basic functions we have that we need to know. So when we know those functions, we can differentiate anything in in mathematics. So what are the basic primary functions we have? We have let me say 5 elementary function. Elementary functions we have in mathematics. Number one, we have y is equals to x raised to power n. That is one function where n is an element of real number. Number two, n is an element of real number. So next one we have is when we have what your trig ratios, but the basic ones are what sine x. Third one is y is equals to cos x. The fourth one is y is equals to ax. So a is a constant. And the fifth one is y is equals to log x base a. So these are the 5 primary functions we need to understand in mathematics. When you understand these 5 primary functions and you can differentiate them, then you can differentiate any other things, because they are the basic and fundamental functions in mathematics. They are very basic. You can't produce them from other functions. In fact, I do call them independent functions, because they are not cannot basic compared to the other ones. The other ones, other functions that have in mathematics are mostly the combination of these. Those are the those are the what? Those are the other functions that can be derived from this. I get it. Though we also have other tools that are also basic like this. Example is y is equals to they are called hyperbolic function, such as and y is equals to cos x. So these are the basic functions we have that are mostly useful. So when you know them, you can differentiate other functions. Okay. So in this video, I'll be talking about the how to use the first principle to solve questions. So most exam questions, they can test you with first principle, which might not look the same way you think it is. And some questions in first principle that might get you into trouble, even though you think you know how to solve it. So, but before that, so to make sure that you are confident of yourself, we can try few examples to know how first principle works. The first one is find the second, find the gradient of second of y is equals to 2x squared plus 3. And the gradient of its tangent. So as I've said in my last video, that we now understand what tangent is and what secant is. Secant is a line that touches a curve at any number of points other than 1, while tangent is a line that touches a curve at just 1 point. So how do you find the gradient of this? So using first principle. Of course, I have a first principle in this video. So let's start with that. We have a function y is equals to 2x squared plus 3. So what we do here is we'll start with the idea as we increase both y and both x at the same time. So what I'll do here is I'll turn this to y plus change in y. So anywhere you see your y, change it to what? Y plus change in y. And anywhere you see your x, it becomes x plus change in x. 3. Can you see? So then y plus change in y, I would love to expand this twice of what is here? We can expand this as x plus change in x multiplied by x plus change in x plus 3. This is what? X squared. This is x change in x. Another x change in x plus change in x all squared plus 3. You can say I multiply this, I have x squared. This and this, I have x and change in x. This and this, also have x and what? And change in x. This change in x is a quantity, so you must not mix the x of it with the x of this. That is the reason why I got the x, this x at the back of this dx to differentiate them. So since we've seen the question, I can clear it. So then we can continue. We have y plus change in y. Using 2 to open it. So you can see there's a 2 here. And now with 2 times x squared is 2x squared. 2 times this plus 2x change in x. 2 times this. So before I continue, these are similar terms. So that should be x squared plus 2x change in x plus change in x squared plus 3. They are similar terms, so that becomes 2 and this plus 3. So in that case, 2 times 2 is 4. So that's 4x change in x, and 2 times this, you have 2 change in x squared, and you have plus 3. Now our goal is to what? Is to make the change in y subject of formula. So what will be here is change in y. I'll bring this here. Minus y. Are you getting? What is the value of y? What is the value of y? The value of y is 2x squared plus 3. So here becomes 2x squared plus 4 change in x plus 2 change in x squared plus 3 minus 2x squared plus 3. You can see I replace the y by its former value. So replace by the former value. And in that case, that becomes 2x squared plus 4x change in x. Okay, I'll be writing it here to make it clearer. So that will become, so my change in y, you can see change in y, I've got this y here, so you are left to change the y on the left hand side, and you are having here 2x squared plus 4x change in x plus 2 change in x squared plus 3 minus times this is minus 2x squared, and minus times this is minus 3. So all you observe here, you can see we add similar terms. You can cancel out. This goes out. This also goes out. So we are left with 4x change in x plus 2 change in x squared. So the next step now is what? Divide all through. by changing x. As well as the next step. Next step is divide all through by changing x. Can divide all through by changing x, and so my change in y by changing x. This cancel this. So you are left with what? 4x. And this is twice, actually this is squared and this is 1. This is raised to power 1. So this can go in this and be left with 1. This cancel this, you will left with dx. So you have plus. Okay, don't let me cancel it. Let me leave it as 2 over changing x. So this in this you are left with what? 2 changing x. So we come to the one part of our answer, our answer to the first question. First question says find the gradient of the second. So this will be my answer. So the gradient of second will be equals, which is equals to this, will be equals to 4x plus 2 changing x. This is my answer to the gradient of the second. Simple as that. So, but the next one is next question. So let me call this question I. Question 2. The gradient of tangent. So how do you find the gradient of the tangent or to the curve? What do you do? On my video that I explained the principle of differentiation, I said you only have the gradient of the tangent when the change in x in this is approaching 0. So when the change in x in second is approaching 0, you have the what? The gradient of the what? Of the tangent. So in that case, I'll say as what? Change in x goes to 0, then my change in y by change in x approaches change in y by change in x approaches to y dx. That will be the so, and the y dx is the what? Is the value of the tangent. Sorry, the value of the gradient of the what? Of the tangent. So what I'll do here is I'll input 0 here. So my dy dx will be equals to 4x. Now anywhere I see my dx, I'll put 0. So you can see in this place now, I have only dx here. So I'm putting 0 there, 2 times 0, and that is equal to 4x plus 0, and that is what? 4x. So my dy dx is equals to 4x. So that's how the what? How to use the first principle by what? By making the what? Changing by changing x is subject of formula. So simple as that. This will be my answer for this. So next question, find the gradient of secant and tangent of curve so find the gradient and tangent of curve y is equals to x plus 10. Let's do that. So I'll be using line here. So we have to find the gradient of secant and tangent of what? Of this line y is equals to x plus 10. So wow, that becomes y plus what? Change in y, and here becomes x plus change in x plus 10. That's the first step you do. Next step is what? You bring the y here, minus y. What's my y? My y in the question, let me write it here. Note my y is equals to x plus 10. X plus 10, you can see. So, okay, so let me continue my writing here. I have x plus change in x plus 10. My y is x plus 10, so that is into brackets x plus 10. X plus change in x minus 10. That will be the so when you open this and you have minus x and you have minus 10, this cancel this cancel this. So if left change in y is equals to what? Change in x. What is the next step? Divide throughout by the x. Divide throughout. By changing x. So that will be change in y over change in x is equals to change in x over what? Change in x. So, okay, we have to find the gradient of the second. So my change in y over change in x, this cancel this, and that is equals to what? 1. So therefore, my gradient of second, which is equals to change in y over change in x, is equals to 1. Simple as that, not hard. Also, my gradient of tangent is equals to the y dx, as we've said before. But to know the y dx, your change in x must approach 0. So your change in y over change in x turns to what? Turns to the gradient of the what? Of the tangent. And in that case, so you can see as this approaches 0, this comes to this. Now what is the value of this? The value of this is 1. Are you getting? So we can see approach is equals to what? Is equals to 1. But is there any change in x in the expression here? No. So to input 0 is not necessary because you don't have any change in x here. It's only when you have change in x here that you can input value of what? Of change in x. But since it does not appear, and that means my dy dx also equals 1. That is my answer. That will be my answer to what? To the question. Okay. So for the third example, now I'm doing the tough question on the first principle. Tough questions that are different from the one we did before. So the first two examples we did are very simple, but this requires a different approach. Now I want to say this: anytime you have powers of y, it's always difficult to solve. But this is what we're doing. So I have powers of y, which is what? Y squared times x plus 3 is equals to what? 20. I want to look for the gradient of this. Very simple. So now we have to find the gradient of the secant. There's one between the gradient of secant and the gradient of tangent. The gradient of secant is change in y by change in x. That is the gradient of the secant. While the gradient of the tangent is when you plug in change in x equals 0 to get my dy dx. That is the gradient of the tangent. Now let's do this. So I have y squared x plus 3 is equals to 20. So in that case, y squared is equals to 20 over x plus 3. That will be it. So here is 20 over x plus 3 because this is the actual function. So what we'll be doing next is you won't take the square root of this just because you want to look for y. No, that is wrong. What you do next is take this. If I say y is equals to the square root of 20 plus x plus 3, long and wrong approach. A wrong approach. You can't take the square root of this because that this y squared means y has two values. It has a positive value and a negative value. So to avoid that mistake, this is a very wrong approach. Don't take this to find value of y and put y plus 10 in y. That is wrong. So what we do here is you expand this one. You expand it itself. Now so this is our first arrangement of what? Of the function given to us. I arrange it. First thing you do is anytime you see powers of y, you arrange it like this to make sure that the y is on the left hand side and the x on the x part are on the right hand side. Next thing you do is now you are looking for the greatest of the second. So what do? You start with your what? Start with your change in y. But then you have y squared. So that becomes y. So you can see I have y squared. It turns to y plus change in y. Everything squared. That equals to 20. So what is it to the x? X also increase. That becomes the x plus change in x plus 3. That will be the what? That will be the x plus 3. The x becomes x plus change in x. And y becomes y plus change in y. So what the next I'll do here is I'll expand this. And how do you expand this? You have y plus change in y times y plus change in y. And that is equal to 20 over x plus change in x plus 3. What will this become? This becomes y squared. This becomes y change in y. This becomes y change in y. And this becomes change in y all squared. That's when I expand this, I have this. And that equals to what? To the other value here, 20 over x plus 10 in x plus 3. So I'll be cleaning this. So here I'll have y squared plus 2y change in y plus change in y all squared equals to 20 x plus 3. Now you can see what you observe here, you can see I have this. I have change in y and I have change in y squared. So it is very hard for me to have change in y alone. But so looking for using the first principle, it's not necessary you have change in y on the left hand side alone. Not necessary. It's not a must. What I'll do here first of all is since I have change in y and change in y here, I can see it at this side. So I have 2y change in y plus change in y squared. But I bring this y to the other side because it contains exactly what is actually in question. So it's 20 over x plus 3 minus y squared. But note, y squared is equals to 20 over x plus 3 in the question given to you. So I'll be using that. For this side, this is common, this is common. So it can become change in y into 2y plus change in y. You can say I have square of this. So square of this means this times this of itself. I take one of it, take one of it out, left with 2y and 1 of this. And that equals to 20 over x plus change in x plus 3. Now what is y squared? This minus 20 over x plus 3. The LCM x plus change in x plus 3 times x plus 3. That will be the LCM. And here, the 20 is here. It's common. Can factorize the 20 here and 20. Well, to avoid doing mistake, I'll do it one by one. So here is this in this is what is this. That is x plus 3. Can you see that? This in this is what is this. And that is, so let me write my stuff here. X plus 3 minus 20. So you have x plus 10 in x plus 3 x. The LCM here is the multiplication of this and this. That is LCM. And this in this is this. This in this is what is this. So you see you have this and you have this. So from there, to avoid stress, I can 20 is common here, the 20 is common here. So instead of wasting time, instead of wasting time, I'll just take 20 is here, 20 is common here, take that one out. So I'm left with x plus 3. Are you getting? Also here, you have a minus here, you can just open this, and that is minus x minus 10 in x minus 3. Then from here, you have x plus 10 in x plus 3, and you have x plus 3. You can see how beautiful this is. So this is it. You use minus to open this. But I did why there is 20 is common here, so that's the 20 out, which is here. So this cancel this, and this cancel this. So from there, you have change in y, 2y plus change in y will equals to 20. You have minus change in x in the bracket, so I'll have change in x here, and here I'll have x plus change in x plus 3 times x plus 3. So the next thing you do here is you have this over this. Next thing you do is make sure you make this the solid of formula as I've said before. So my change in y here equals to so it has a long denominator, which is 2y plus change in y divided both sides by this, and I have x plus change in x plus 3 x plus 3 minus change in x. Now we are changing y. So here we can now what? Divide throughout by a change in x. That will be the next thing you do. So that will be change in y over change in x. Can you see? Change in y over change in x. And that will be 20 minus change in x over this. So I have 2y plus change in y. I have x plus change in x plus 3, and I have x plus 3. This expression will be multiplied by, I will have to shift this backward, so to make my work neutral, I have 20 over minus change in x times 1 over change in x. So here I'll have 2y plus change in y, and I have x plus change in x plus 3, x plus 3, I have change in y over change in x here. So this can say divide by what? I change in x, so I do this. So when you do this, it also means you are multiplying it by what? 1 over change in x. So this cancel this. Are you getting? So that will be what? Minus 20 over, so my change in y over change in x be 2y plus changing y, x plus changing x plus 3 and x plus 3. That will be the answer to the what? That will be the gradient of the what? Of y squared times x plus 3 is equal to 20. This will be the answer to that. Simple as that. So those are the what type of hard questions you can come about in using the first principle to find the gradient, to find the y the x, or you find the what? Change the y by changing x. This type of questions, you can see it contains the y and it contains y. Most people are familiar with the fact that change in y by changing x to contain only change in x alone. But unfortunately, it's not so. It can contain change in y and contain y and contain any value whatsoever. So this should be our answer to that. Also, so let me do a fourth example before we go. I'll give fourth example, which is y is equals to find the y dx using first principle. Using first principle, find first principle for y is equals to 3x minus 10. Let's do this together. So I'll make it y squared is equal to 3x minus 10. How do you find the y dx of this? We'll be doing two things here. We'll be doing the gradient of seconds, which is changing y by changing x, and also be doing the what? The gradient of the tangent, which is what? Which is the y dx. I'll be doing both so you can see different answers you can have. So how do you do this? The same step. That'll be y changing y. You can say this is square. Y squared is equal to 3x minus 10. Let me write it here. Note y squared is equal to 3x minus 10. So square is equal to 3 into bracket x plus changing x minus 10. Then this becomes, the left hand side, this becomes y squared plus 2y changing y plus changing y squared is equals to 3x plus 3 changing x minus 10. That will be the what? That will be the, can 3 times x is 3x, 3 times this is 3 dx minus 10, and you expanded this. So this, I will leave this to the left hand side. I'll be left with 2y changing y plus changing y squared, and that will be equals to 3x plus 3 changing x minus 10 minus, body to that side, y squared. By using that, and that becomes 3x plus 3 changing x minus 10 minus, my y squared is 3x minus 10. So that becomes 3x plus 3 changing x minus 10 is minus 3x. This is plus 10. Can you see that? So this cancel this cancel this. I'll be left with 3 change x at the left hand side here, and here I'll have 2y changing y plus changing y squared is equals to 3 changing x. All out here is factor. I'll take one changing y out, and that leaves me with 2y plus changing y, and that is equals to what? 3 changing x. So my changing y is equals to 3 changing x over 2y plus changing y. You can see. So I divided both sides by what? By this. Next step I'll be doing is divide by changing x. So that will be changing y over changing x. Equal to 3 changing x, 2y plus changing y, times 1 over changing x. I just have to look for that. This cancel this. So you have changing y over changing x is equals to 3 over 2y plus changing y. That will be your answer. So this will be the gradient of the secant. Y for tangent, gradient of tangent. Gradient of tangent, the dx will approach 0. And in that case, you can see here, there's no dx here. But I should have also said this also. The dx and the dy must approach 0 at the same time in differentiation. Your dx is approaching 0, your dy is approaching 0. Because as you are turning the curve down, both of it is what is becoming 0. So in that case, the value of this also what becomes 0. So my change in y over change in x becomes the y dx. When you put what? When you put 0 here, that's 2y plus 0. And that equals what? 3 over 2y. So that will be the answer to what? To the value of the question, which is what? Our y is equal to what? 3 over 2y. I'm using the what? First principles to solve these questions.